Welcome to this new section dedicated for learning about arrays in C. Now in this particular lecture, we're going to learn about following topics. We're going to learn about what is an array. Then we're going to learn about why is array actually needed. Okay, what is the need behind the array? And then we are going to see how to create our own array, how we can define our own array, and then how we can process the array that we have already created. Okay, so this is the content of this lecture. So let's get started. Now the question is, what is an array? Array is nothing but it's a collection or list of similar kind of elements. So there are some of the examples that is cited here. So let's say you are collecting the list of names. So let's say if I say list of names, it's a collection of names. I have more than one names collected in a single place. So that is an array, that is a list. So here I have three names, Kavyanjali, Vedansi, and Chidanvi. So I've collected three names in a list. So it is called as a list of names. Okay. So you can have similarly collection of scores. Let's say the score of students in a particular subject. Okay. So these are the scores out of 100. 58 the score of the first person, 72 is the score of the second person, 63 is the score of the third person, and so on so forth. You have many such scores collected together in a single place. That is called as a list or as an array. Okay, so there's a collection of scores. So if you see here in collection of scores, all these marks are of type integers. Similarly, if you see here in the collection of names, all the names are of type string. Okay, so it is a collection of elements of similar type. So they must be of same type. Okay, so I can't have something like this 12.5, a floating point number, 2 is an integer number, and CBA, this is a string. This is also a collection, but this is a collection of elements of different type. So this is not qualified to be called as an array in C. Okay, so in C, if you are calling array, it must be a collection of similar elements. Okay, similarly, let's say your mother has asked you to go to market to get some items. So she has given you a shopping list. So shopping list is nothing but it's a list of items, right? So this is a string. So tomato 2 kg, potato 5 kg, rice 10 kg, dal 2 kg. So this is a list of items that is to be procured from the market. So this is a shopping list. It's again an array. Okay, it's a collection of strings. So I hope you have understood what is an array in this particular slide. Now let's learn what is the need behind array. Okay, why we are going to use array in our programming. Okay, so why is array actually needed? That's what we're going to learn in this slide. Okay, so let's take a problem first of all to understand this. So you're supposed to store marks scored by 50 different students in a particular subject in a class. Okay, let's say the subject is C programming. So in a C programming subject, there are 50 students enrolled. So I need to store marks of all these students together. Let's say you don't know anything about an array. So what you do here is, because you have to store 50 different marks, you will be needing 50 different variables, right? Let's say marks is a floating point number because you can score 50.6, 19.3. So marks is a floating point number. So what you can write is, you can write float M1, that will store marks 1. Similarly, comma M2, it will store the marks of the second student. M3, it will store the marks of the third student, and so on so forth. You will keep on writing up to M50, which will store the marks of 50th student, right? So here you are creating 50 different variables, right? So you are supposed to store the marks of 50 different students. You need 50 different variables. But let's say you are supposed to store the marks of 100 different students. In that case, you will be needing 100 different variables. So if the university is quite large, let's say in a course there are 500 students enrolled, so you'll have to have 500 different variables to store marks of 500 different students. It is quite difficult to manage 50 different variables. Now let's say you are having 100 students, difficult to manage 100 variables, right? So as and when you have more number of variables in a program, it is quite difficult to manage and maintain that program. So if we can use array here, what we get as a feature is that array will help you to manage all these different 50 different variables using a single name. So that's the advantage of an array. Array helps us to manage the list of similar kind of a data in a very efficient way. Okay, so now we are going to learn that here. Let's say how we can create our own array. So here, let's say we are supposed to create an array to store the marks of or the score of 50 different students. So the syntax first of all for creating an array is, first you need to provide the data type. Okay, so let's say each score is of type float. So I'll write data type is float. Okay, each marks is a float value, and you give space and then you have to write the name of the array. So it can be of any valid identifier name. So let me give it as marks, like marks, and then I have this square bracket open, and then here I'll give a number that is the size of my array. So I'm going to store 50 different scores, so I'll have to write 50 here. So this is very simple, okay? With just one single line, I'll be able to create a space for storing 50 different marks. Now let's say I would like to create one more array. I would like to create an integer array. So I write int, so data type is int. So name of the array, let me call it as A. A is the name of the array, and let's say the size is 5, okay? So in this array is of type integer, so it can only hold integer values. But how many integer values? There are 5 different integer values, and name of the array is A. Okay, so this is how you can actually create the array. Now let's try to visualize how is this array stored in the memory. So in the memory, what is going to happen is it is going to reserve an entire block of memory for me, wherein I can store 5 different marks. So there will be 5 compartments created for me. 1, 2, 3, 4, 5 compartments. Okay, now each of this compartment will be given a particular index value. Okay, so the first compartment is identified by the index 0. Okay, the second element will be identified by the index 1, index 2, index 3, and index 4. So whenever you have the array of size 5, the index will range from 0 to 4. Okay, so 0 is the first place where I can actually store the value. So each of these boxes are of the size of integer. So the size of this box is equivalent to the size of integer. So if size of integer is 4 bytes, so this is 4 bytes plus 4 bytes plus 4 bytes. So there are 5 times 4 bytes. So it is 5 times 4 is equals to 20 bytes. So entirely I'll be allocated 20 bytes of memory. This entire thing is 20 bytes long. Now 20 bytes is partitioned into 5 different chunks. Each chunk is capable of holding each integer value. When you are creating an array like this, here I have not initialized the values to the array. I have not assigned any values to the array. Therefore, each of these elements will hold a garbage value. Okay, so inside this box there's a garbage value. All these values are garbage value. Okay, now let's see how we can actually initialize our array. Okay, let's take the same array. I write int a5. So I'm creating the array of size 5. If I want to initialize this array with 5 different elements, what I do is I write equals to. Okay, I open a curly brace like this and close the curly brace, have a semicolon at the end. Now all the 5 values I'll have to write here, and all these 5 values must be an integer value because I'm holding integer value. This is my integer array. Now all these 5 values are separated by comma. So I'll write 5, 6, 2, 3, 8. So these are 5 values that will be stored in this array A. So this is my array A. Okay, it has 5 compartments, 1, 2, 3, 4, 5. Okay, the first compartment is having the index 0, index 1, index 2, index 3, and index 4. Okay, what is the value stored in index 0? So at index 0, the value is 5. At index 1, the value is 6. Index 2, index 3, and index 4. Okay, so I'll write down here at index 0, the value is 5. At index 1, the value is 6. This is 2. At index 3, the value is 3. And index 4, the value is 8. So this is how the values are stored. Now you may be wondering, how do I access the values, right? So how do I access the value at, let's say, index 2? How do I access the value of index 2? It's very simple. I have to give the name of the array. So name of the array is what? Name of the array is A. And then I'll have to open the square bracket like this. And inside the square bracket, I'll give the index. So index is 2. So I say A2. Whenever I write A2, I mean the value is 2. Whenever I write A4, what do I get? I'm trying to access the value at index 4. So at index 4, the value is 8. So A4 is as good as this value 8. Similarly, this is nothing but A0. This is nothing but A1. Okay. This is nothing but A3. Okay. This is how you can actually access the values. Okay. Now this kind of a initialization is called as the compile time initialization. Okay, in this case I'm initializing the value at compile time. Okay, before the program runs, it is actually already initialized. The values are already initialized. Okay, now in this case I can also do like this. I can write int a and I do not give the size here, and then I give the values 1, 2, 3, 4, 5. Okay, now if I try to initialize the array like this, okay, this is also all right. This is okay. Okay, here although I have not given the size, but because I have given 5 values here, the compiler will come to know that, okay, this array is of size 5. So it will automatically create the array of size 5 for us, and it will assign these values 1, 2, 3, 4, 5 in that array. Now what may happen if I create an array B like this, okay, of size, let's say 5, but while initializing, I only initialize 2 values, or let's say 3 values. I assign 8, 6 and 9. Okay, I have only initialized 3 values, so B would be allocated a big chunk of memory where it can hold 5 different values. So the indexes here would be index 0, index 1, index 2, index 3 and index 4. Okay, now in this case the first 3 values are already given to me. The first value is nothing but 8, the second value is 6, and the value at index 2 is 9. Here I have not assigned the value at index 3 and index 4, so by default it will take the value to be as 0. So by default the value stored here would be 0. Okay, this is how you can actually initialize your array during the compile time. Now let's see how we can initialize the array during runtime. Now while the program is running, during that time I would like to initialize the array. Let's say I would like the user to press the numbers and then those values should be entered into the array. How do you do that? Okay, so let's learn runtime initialization of an array. Let's say I've got an array called as ARR. The array is of type float, so I write float ARR and the array size is, let's say, 3. Okay, now I would like to initialize this array from the user. Okay, let the user give the values for this array. So in the memory, this array would look like this, ARR. Okay, so it will be allocated 3 boxes for me. Each box is capable of holding the float value, index 0, index 1, index 2. Okay, this value is nothing but ARR 0. Okay, value at index 1 is represented by ARR 1 and the value at index 2 is represented by ARR 2. Okay, so this is how you can access the values of an array. Okay, now I would like to initialize this not during the compile time, but I would like to ask the user to enter the values, because now if you see here, the indexing in the array starts from 0, right? And each time the array index is added by 1, so 0 plus 1 becomes 1 and 1 plus 1 becomes 2, right? I go up to 2. So I can use a for loop, and inside the for loop can ask the user to enter the value, right? So I can run a loop starting from I equals to 0 to I equals to 2. Okay, so what I can do here is I'll write int I is the index for running the for loop. So I'll write for loop for I equals to 0, because 0 is the first index, right? And I must be less than 3, less than the size. This is the size. Okay, this is the size is 3. Okay, less than 3 means it will go up to 2. Okay, each time I is incremented by 1. Okay, so this loop will run for 3 times, once for I equals to 0, second time for I equals to 1 and third time for I equals to 2. Okay, whenever I equals to 3, the condition fails and then loop does not go into the body. Okay, it will come out of the loop. Now to get the number from the user, I'll use scanf here inside the loop, because I would like to run this scanf for 3 times because I need to take 3 different numbers. So I'll write scanf. I'm taking the floating point number, so I'll write %f format specifier, right? And then what do I write here? What do I write here? How do I get the address of this variable? It's very simple. Address of this variable is nothing but I just write ampersand ARR 0, address of the first element. Okay, address of the second element is nothing but ampersand will give the address ARR 1. Similarly, ampersand ARR 2 for the address of the third variable. Okay, so here I'll write ampersand will give me the address of what? Of the array ARR at index I. Okay, at index I. Okay, here I'm taking the array at index I. So I'll write ampersand ARR I. It will scan the value and that value will now be stored in the location where it has to be stored. Okay, so for the first time, let's say user enters the value as 6, so 6 will be stored at index I, that is 0 initially. Then I gets incremented, I becomes 1. So at index 1, let's say the user enters the value 8, so 8 comes here. So I gets incremented, now I becomes 2, right? So at index 2, that is ARR, I is 2, so I becomes 2. So ARR 2 is nothing but the address of this element. Okay, so at this location the value would be stored. The value here, let's say the user enters 10, so all these 3 values will be stored in this way. Okay, so this is how you can actually scan the value or the array elements from the user. This is called as the runtime initialization, because once the program is being executed, once it is running, the user presses the values and now those values are stored in the array. So this is called as the runtime initialization. You can easily do this using a loop. Okay, now let's see how we can process our array by actually solving this problem. Okay, so let's say we have already created an array called as A I have not given the size here, but I have provided 5 elements, so it will create the array A of size 5. Okay, so there are 5 elements, 2, 6, 8, 1, 9. What you are supposed to do is you are supposed to find the sum of all these elements. Okay, so initially let's assume that sum is equals to 0. I have initialized sum as 0 because I don't know what is the sum. So initially my sum is 0. Now I need to catch hold of each of these numbers in the array and add that to my sum, right? So I have to run a loop starting from I equals to 0 to I equals to 5, right? So I run a loop for I equals to 0, okay, I less than equals to 4, or I can write I less than 5 also, right? So I less than 5 because 5 is the size of my array. I less than 5, I plus plus, okay. Now here I've already got my values stored in the array, so it's very easy for me to access the values. If I write AI, I'll get the element at index I. Okay, so let's say initially I is 0, so whenever I write A0 I get this value 2, so I need to add this to my sum variable. So I'll write sum is equals to previous sum plus AI. So initially sum was 0, so whenever I is 0, now A0 would be 2, so 2 would be added in the sum, so 0 plus 2, the answer is 2. So this is my sum now, updated sum. At the next iteration I becomes 1. Right, now next value of I is 1. So at index 1 the value is 6. So 6 is added to sum. So 6 plus 2 becomes 8. 8 is my new sum. Right. So similarly 8 plus 8. Next time I becomes 2. So at index 2 the value is 8. So 8 plus 8 becomes 16. Similarly plus 1 this is added. This becomes 17. 17 plus 9 this becomes 26. Okay, this is how you get the answer. Okay, so sum of all these elements are 26. So after this loop is done, you can just have a display statement here, printf statement, to actually print the value, that is this sum. So I'll write printf, okay, sum equals to %d, and then I'll write sum. Okay, here instead of pf you need to write the entire printf statement. Okay, so this is how it works. Now here you may be wondering, how do I get the size of the array? Here size is 5, but how do I know that size is actually 5? It could have been 10 also, right? Because if there are 5 elements stored, we say that size is 5. Okay, if there are 10 elements stored, the size is 10. But how do I know how many elements are stored in this array? So for that you can use a very simple trick. You know the size of operator, right? So if I do size of my array A, what happens? Size of array is how many bytes? Because each element, let's say integer is of 4 bytes. So 4 bytes plus 4 bytes plus 4 bytes, how many times? 1, 2, 3, 4, 5 times. So this is nothing but 4 times 5, this is 20 bytes. Okay, if I do size of A, it will give me 20 as the answer, right? Now each element is of integer type, so I can write size of int. What is the size of int? Size of int in this machine, let's say, is 4 bytes, because 4 bytes plus 4 bytes plus 4 bytes here makes 20 bytes. So here we are assuming that size of integer is 4 bytes. In some of the machines it can be 2 bytes also, but let's say size of int will give you the size of integer, right? Now how do I know how many elements are there in this array? It's very simple. Number of elements in this array is nothing but 20 divided by 4. If I divide 20 by 4, I get 5. 5 is the number of elements in this array, or we call it as size of the array. So it's very simple. To get this 5, you have to divide size of the array divided by size of integer. Okay, let's say this array is of type float, so you have to write size of A divided by size of float. If this is the array of characters, then you have to write size of A, that will give you the size of the entire array, divided by size of char. Okay, it's very simple. Okay, so this is how you can actually process your array. So that's all in this lecture. In this lecture, the array concept is introduced. We have discussed what is an array, why is array actually needed, and how we can actually create our own array, how we can do runtime initialization, compile time initialization, how we can actually process the array by using a loop. Okay, that is what we have learned in this particular lecture. This was an introductory lecture on array. We're going to learn more interesting stuffs about the array in our subsequent lectures. Until then, stay tuned.